What's up guys, Sir Gian here, and for tonight we're going to have a tutorial about I/O bus for operating systems. Okay, so we have our sample problem and the bus problem here. So for this problem, okay, for a given system, a CPU and memory share a 32-bit bus running at 100 MHz. The memory reads 50 nanoseconds to access 64-bit value from one address. How long will it take to read one address of memory? So we're going to solve here is the time it needs to read one address of memory. So what are the steps that we're going to perform here? So the best thing that we're going to do first here is to get the time it needs to run a single cycle. So we have here the frequency 100 megahertz, okay? So we know that the frequency is equals to 1 over the time, okay? So we have frequency is equal to 100, so we can cross multiply this 2, so that we'll have time is equal to 1 over the frequency, okay? So time required for one cycle would then be equal to 1 over 100 times 10 raised to 6, or that is simply equal to 1 over 1 times 10 to the 9th, okay. Or that would be equal to 10 nanoseconds, okay. So that would be the time required to complete one cycle. So now, it said that the memory needs to be 50 seconds to access 64-bit value from one address, okay. And 32-bit needs 10 nanoseconds, okay? And 32-bit will be one cycle. So for every cycle, it needs 10 nanoseconds. So we have here 3 conditions, okay? And we need to tabulate all that up, okay? So for every 32-bit, okay, that would be one cycle, okay? For 64-bit, okay, we can divide that by another 32-bit, and that would be 2 cycles. And according to the problem, it needs 50 nanoseconds to access 64-bit value. So for 64-bit value, okay, so it requires 50 nanoseconds, okay. So we have 1 cycle, 2 cycle, okay. So 50 cycles divided by 10 nanoseconds per cycle, so that would be 50 nanoseconds over 10 nanoseconds, and that will give us 5 cycles. Okay, so we have here 1 cycle, we have here 2 cycles, we have here 5 cycles. So add that up, so 1 cycle plus 2 cycle plus 3 cycle, rather 5 cycles, and that will give you 8 cycles. Okay. And 8 cycles per cycle, we have 10 nanoseconds. We need the time it needs to access one address of memory. So if we have here 8 cycles, okay, so 8 cycles, and for every cycle, we need 10 nanoseconds. So therefore, to access the data, so cycles and cycles, I can cancel that out. So we have here 80 nanoseconds of time needed to complete the cycles, or to complete 8 cycles, and that would be the time needed to read one address of memory. Okay? So do you have any questions regarding this problem? So if you have any problems, you have any questions, don't hesitate to send me a private message.